ladies and gentlemen, and now Fractals, an exploration of the evolving symmetry, presented by Framestore.
Close. Missed it by that much. Hello, ladies and gentlemen. All right. Welcome to the single finest panel on fractals you will find at this conference this weekend. I have here to my left a variety of experts. We have Anders, is it Hjemdahl? Yeah. Anders Hjemdahl, David Hutchins, Nick Shelton, and Johannes Saam. I'm going to let them introduce themselves. We're going to frame this a little bit, so we're going to talk about fractals with an eye towards the artistic end result, rather than doing a deep dive on the mathematics side of things, since this is a VR conference and the visual result is really what we're going for. Anders, why don't we start with you?
This on? So my name is Anders Hjemdahl, and I'm a creative technologist, developer, and designer, and I have been focusing on VR for the past 4 or 5 years, producing projects for Uber, Oculus, National Wildlife Federation, and others. I'm also a fractal artist, and I've been doing that since around 1990, when I first dove into the Mandelbrot set and never came up, basically. And the past 5, 6 years, I've been doing 3D fractals as well. And of course, in VR, which is a fantastic medium for exploring fractals.
Hi, my name is David Hutchins. I'm an effects supervisor at Walt Disney Animation Studios, currently working on Wreck-It Ralph 2. My primary experience with fractals was working on the film Big Hero 6, and there was a sequence at the end of the movie where we created an environment entirely out of mandelbulbs and mandelbulb hybrids. That's how I came to be on this panel, thanks to Johannes' connection that he knows, who also worked with me, Jesse Eriksson. That was an interesting introduction to the fractal algorithms for me. They're kind of turned out to be tricky to render in 3D, but it was a really fascinating exploration. I was really happy with the results that we got.
Hi, my name is Johannes Saam. I am the senior creative developer at Framestore, not Stone. And we are doing VR, AR, MR, whatever there is experiences, as well as our 30 years track record of doing visual effects for film and commercials. So recently, out of LA, we have started a team of interactive designers and artists and programmers that help us visualizing what we call interactive entertainment branch of the business, which is obviously a lot in VR. And one of our products tools is called Coral, which is on display actually in the Visionary Arts Zone down at the show floor, which is a fractal explorer in VR. So what we specialize in is then taking the algorithms and not taking the long render times and trying to render them as quickly as possible, 90 hertz for the VR headsets. And that's what we focus on besides other VR experiences. I was still not in high school when you looked Mandelbrot up the first time, Anders. So our exposure is shorter, but faster, literally.
I would say you've compensated pretty well.
Okay.
Hello, my name is Nick Shelton. I'm a graphics developer at TheWaveVR. I've been experimenting with real-time 3D fractals for the last 5 years. Right now I'm working on VR fractals, primarily for TheWaveVR, which is a live music social platform in VR, so you can go to concerts and see sweet fractals with crazy music DJs. And yeah, happy to be here.
Okay, sounds good. Now, a couple of things to note, guys. We're not going to do a Q&A, like we're not going to do like lecture and then Q&A. We want you guys to ask your questions as they come to mind. The one caveat, the one rule, is you must use that microphone. So if you have a question, stand up quietly, move to the mic, and we will direct our attention to you as soon as we see you at the mic. If you're shouting from the back of the room, we'll smile and wave, but we probably won't be able to hear a word you said. So we're not ignoring you, we just can't tell that you're asking a question. So please move to the mic as we go along. Okay, I'm gonna move. All right. So first of all, let's talk a little bit about fractals as you guys are using them. Every single one of you is using fractals in an artistic form rather than a pure mathematical form. Does anybody want to talk about sort of how you define fractals when you're working with teams or you're working with teams of artists in order to describe what it is that you're looking for an end result?
Sure, I can start with that. So for us, what the beauty of it is, it's actually the simplicity in the mathematical formulas. So if you're a math PhD, you might be bored. But if you're a graphics programmer who's kind of trying to understand the math, it's a very quick way of generating a lot of content. So for us, with the VR Explorer for Coral, it's literally an infinite experience. You can fly in one direction as long as you want, with caveats, of course, but you can fly for a long time and seeing new content and ever-changing content that in times where, explorable worlds that are created by teams of hundreds of thousands of artists in games is very interesting for us to actually have a space where fractals play and the formulas play out very well for that space. And in general, I mean, one of the inventors of fractals, Mr. Mandelbrot himself, always calls them beautiful, damn hard, and increasingly important. And I think that's interesting. So there's more and more formulas that are in that space that come out. More and more people experiment with combining them. That are, there are forums out there that lots of the credits of our work, probably if everybody goes to like fractalforums.org, and the artists in that space that inspire us. And I think that's a very important part.
Interesting fact about fractal forums is that the 3D fractals were actually discovered at the fractal forums, at a discussion thread there. So that's how they came about. Two guys, Paul Nylander and David White, I think.
Yeah, that's right. And that was some of the inspiration that we used for our work on Big Hero 6. I share the fascination that Johannes was mentioning about the simplicity of the math. In one of the slides, you'll see actually the algorithm that we used for our variation on the Mandelbrot. And it's kind of deceptively simple, as so many kind of algorithms that we use, that I use in my day-to-day job, visual effects, are. What's interesting to me in the general sense about fractals is that self-similarity on multiple scales is something that we see in nature all over the place. And it really is that simple concept of an infinitude of detail is something that makes nature, it evokes reality, which is something that we're always trying to do with our work at Disney Animation. Even though we're making animated cartoons, we try to make the worlds believable and the worlds immersive. And in the case of Big Hero 6, we needed to make an environment that was supposed to be a malfunctioning wormhole. No one really knew what that was, but there were some theories of that we took from science about the structure of space-time at very small scales below the Planck length, which is extremely small, where quantum effects start to take over. And there are some theories that the geometry of space-time at those scales is fractal. So that was the inspiration that got us down that path.
I think this This is one of the most compelling things about fractals you guys are touching on. So you have these really simple rules, and then just iterating the formula, you can get this vast complexity, which kind of shows a fundamental property of the universe. And so when you're talking about using them for artistic uses, you basically just set it running, and then you just explore, and you can find, it becomes more of like finding the really interesting bits and like composing the kind of shots and environments you want, and you're kind of exploring at that point, which is kind of the coolest part.
It's absolutely true, and one of the best uses in film, besides Big Hero 6, was in Guardians of the Galaxy Volume 2, Inigo's Planet, and that's very good friends with the people who made this, and they gave a public talk last year, and they literally did that. They did basically a version of Coral that ran at, you know, very low frame rates, but they could kind of dive into a fractal move, watch the world evolve, and then just find areas that they like, and then capture those and put them into meshes, and then go into the regular visual effects rendering pipeline. So I think that's what excites us. Is just every time I jump into a fractal, I find new ways, or every time I see somebody exploring it, they see different areas that I haven't seen before, and it's all the same simple math, which is quite astonishing.
I think it's interesting also that to sort of keep in mind that a lot of the things that we see when we go to see any film, basically these days, you see a lot of fractals everywhere. Not only the obvious fractals, like fractal-looking fractals, like in Big Hero 6 and other films, but pretty much any sky that you see, any water mass that you see, any terrain that you see, forests, grass, all of that is fractals, usually. I mean, unless you're shooting at a live site. So using fractals for that is obviously, you know, very handy when you want to create a forest with 10 billion trees. You just generate it immediately using a fractal. But it's fascinating to actually watch the fractal objects that are generated by the algorithm itself displaying the same kind of behavior. So, but it's not trees or terrain, but these weird-looking shapes that you can explore forever. So I don't know how many of you have actually explored fractals. I guess quite a few of you have at least tried it. But you should really go and check it out for yourself.
I'm glad you brought up the terrain generation algorithms, because those have been around for many, many, many years. And people don't often think of them as classic fractals, but they are fractal algorithms. And the classic turbulent noise, which is just a mainstay of visual effects, is itself a fractal algorithm. And, you know, patterns like the trees or the, you know, mountains and things like that have been, since the 80s, generated purely procedurally.
And that's why, Kimberly, when you told us how you got into fractals, I think it's a very worthwhile endeavor to tell the audience that how you used that into non-visual ways of algorithms, which I think was very exciting.
Well, we were using fractals a number of years ago to help generate enemy path noting and decision making. So you could get a more naturalistic decision tree about how an enemy character would move through the environment. The problem we ran into is that the enemies were more difficult for the players to handle, because at that point in time, one of the things you do as a game player is you watch for patterns, right? As humans, we're all very pattern-centric. So eventually, I think we'll come back around and visit it, particularly with the way things are going with AI for those types of decision-making actions.
I think that's very good that we, as I said, it's getting increasingly important. I think the fractal nature of the universe or of nature out there just leads towards algorithms in any sort of industry. They're not necessarily graphics that will be solvable like that. Just because in visual effects, if you start just with a random noise, it just doesn't look natural. And then if you start applying the actual rules of nature, how they happen to be, and it extends to music as well. If you look at compositions and the way they are structured, it's all the same at the end. So maybe we're just looking just a slight little bit behind the matrix with all this stuff.
Speaking of the matrix, I think that's sort of the main part of the fascination that fractals hold for me, is that they represent possibly a key to the underlying mechanisms of the universe, at least closer to the actual workings of the universe than normal Euclidean geometry is. For instance, all your cell phones contain a fractal antenna, which gives it much, much better coverage. Your lungs are fractals, your nervous systems are fractals. So we have fractals basically at all scales in everything in nature and in a lot of things that we produce. So I think fractals, just the fact that they represent the universe in this way, I think is possibly a key to furthering our understanding of things and learning new things about the universe as well.
One of the interesting things about fractals is that people experience them in multiple dimensions as well. Most of us were introduced to fractals as a 2D pattern somewhere, right? A trippy poster you had on your wall in high school, something you saw in the background of a Discovery Channel show. But from there, we've moved into 3D, and you've got 3D printed fractals. And then if you want to take it one step further, when we're working in things like live VR, we're actually working in 4D fractal patterns, right? We've moved into time as opposed to just having it be a sole visual representation. When you guys are addressing a project, do you focus on one dimension? Do you approach it differently if you know you're going to 2D versus you're going to something that's got to animate and move on the fly?
It's, I think doing 2D fractals, at least for me artistically, I try to create a sense of depth because, like I was saying about how the fractals represent a key to how the universe works, for me, that's awe-inspiring. So that's the feeling that I want to capture in my art, this sense of awe and this sense of something astounding going on some level. We don't know what it is, but it's something there which is pretty fascinating. So 2D fractals, for me, is creating depth and creating the right color palette that takes the longest time. And of course, the exploration also, but 3D is so much more complicated. And obviously, fractals are endlessly complex. So first of all, exploring them takes a long time, but also for doing anything that is animated, you need to find fractals that are efficient and feasible to animate and render. I mean, sometimes a single frame that I do can take a couple of days to render, and that's one frame.
That's cheating. I have 11 milliseconds.
Except we're sort of on opposite scale, parts of the scale. I mean, these guys do stuff in real time. I do stuff sort of anti-real time. So that's a big consideration to just find fractals, combinations of fractal formulas. We do a lot of hybrids, I think all of us, combining different fractal formulas and finding the sweet spots. But finding those places inside of fractals that are fast to render and that are workable. And I mean, when doing stuff in real time, obviously that's a major consideration.
My first introduction to fractals and how they might be used for visual effects was seeing the Mandelbrot. There was a video on Vimeo a few years back of a Mandelbrot actually evolving over time. So it had that time element as part of it. And I had seen, as we all had 2D fractal patterns over the years, but there was something about that video that was incredibly evocative and a little bit unsettling as well. And I would have never connected it to the actual 2D Mandelbrot set, having first seen it. But for us, that was the inspiration that led us to think, well, could we turn this into an environment? And we had to kind of populate a whole volume of space with Mandelbrot's to do that. And we were definitely not in the real-time realm there. I mean, we were spending a few probably hours per frame just to rasterize, because we were working with volumetric data to render something that looked somewhat cloud-like and wispy. So it would take here's an image from Big Hero 6. We were taking on the order of 2 to 3 hours per frame to rasterize, and then it had to go through rendering, which was another multiple. I don't know how many core hours, maybe 50 to 100 core hours per frame to render. But for me personally, that time element added to the Mandelbrot algorithm was what was really fascinating and got me interested.
I remember the first time that I created a fractal for VR. It was something that I always wanted to do, to even see a 3D fractal, but it was a very hard problem to solve mathematically to create the Mandelbrot set in 3D. So, and there's still a debate that what we're doing is an actual real
Right, exactly.
Mandelbrot.
Yeah.
It's not perfectly kosher.
It's not, and it has a seam, of course. It doesn't actually, it only at certain rotational values does it actually seam together properly.
Yeah.
You can clearly see that the fractal math is actually a live subject. So it's not solved. It's like there's still a debate on how it works.
There is even given and we saw the algorithm for the 2D Mandelbrot just a couple slides ago, and the algorithm that we used simply is taking that 2D algorithm and extrapolating it into 3D using polar coordinates. So we needed to rasterize in X, Y, and Z, so we needed to find a value of a pixel for those 3 dimensions based on its position in those 3 dimensions. But the way that we do that is by extrapolating that, what is a 2D algorithm, just on 2 axes to a 3-axis coordinate system by passing it through polar coordinates, and by modulating the three terms of the polar coordinates, we are able to generate the hybrids and also the evolution, the time evolution of our particular fractal.
Speaking of hybrid fractals, to make things even more complicated, a lot of the fractals that are used are 5 or even 6 dimensionals, and then projected back into 3D space. So there's a lot of weird stuff going on.
That sounds hard. That's too hard. I wouldn't.
Yeah, and anything over 7-dimensional spaces is not real timeable. No. But I think that to go back to the roots of how we got into fractals and stuff like this, what got me about it when I first learned about it as just like interested in graphics, doing visual effects, is that I assumed it must be humongously complicated to create those, and the formulas must be 70 pages long SIGGRAPH papers from the early 90s written in a typewriter. But turns out, once you look at the code, it's actually not that complicated, and you start to kind of intuitively get a feeling for it. It's really, really weird. That's why I think there's a lot of fractal artists out there that are not necessarily math majors, or I think the math majors are more interested in their mathematical properties and how they play out in describing quantum mechanics and all this kind of stuff, depending, the multiverse view of it. But as the artist point of view, to kind of roll it a little bit back into the artist realm for VR and VRLA, is that once you play with it and play with the formulas and play with the properties of it and visually see what's happening, it is in a way weirdly intuitive, and you can start to understand patterns yourself, and you understand how it works. And by that, it's a very artist-friendly tool in a way. I mean, it's still mathematically complex, but I almost failed high school because of math. Like, I'm definitely not a math major. But you can still explore and come up with new fractals. So I think part of Coral is actually one fractal that Mariano in the first row kind of created by himself, and it's actually the world's first. And we also tried our optimizations for the Mandelbrot. Everybody tries that, and we came up with something. And I think you can still add to this subject. It's not like a dusty academic only math major project. You can, by just experimenting with it, actually come up with new mathematical constructs that are actually meaningful for other areas, which is, I think, quite exciting for people. So I don't want to get people too scared because we said the word math 3 times, like Beetlejuice.
I mean, really, creating fractals is very, very easy. Making them look the way that you want them to can be very, very hard. But creating fractals is basically messing around with software and experimenting and pulling on sliders and having things go wrong a lot of the time, and then gradually finding your way to create the stuff that you want to create. It's not hard at all to get started with it. But picking up on what you were saying about simplicity, I think that's a key attraction. At least for me, what fractals represent is that to get that astounding complexity from something that is so simple, it's something that to me is really important and a lesson on how things can work. Like the Scottish poet William Blake put it really well when he said that you can have eternity in a grain of sand and heaven in a wildflower just because of the complexity that it represents. I think that is really true about fractals as well. And we actually call formulas seeds sometimes. So I think that's very appropriate.
Absolutely, and as I kind of tried to hint before, and it's where your expertise comes in, is if you mix it up with music and other generative or rule-based art. Like music is kind of a rule-based system that plays to. I mean, people break it, and it's the same with everything. But down at the core, there's a certain set of things that are pretty, certain ratios, certain algorithms that are created, and that's what you guys do. You actually, you look at music and then come up with the formulas for it, which is, I think, also a perfect kind of combination of different disciplines actually at the same time.
Yeah, like this image you're seeing right now, going back to the simplicity, it could be like 10 lines of code in a shader can generate the geometry that you're seeing here. And that was like kind of what drew me to it. The first time I got VR, I was like, I have to put my head in this in VR, and just got lost for months doing that. But because it's so simple, you can really strip it down. I mean, you have to do real-time VR stuff. So it's crazy hearing you guys say like hours to render a frame. But once you do have it real time, then you are able to do like real-time audio analysis or put it in with a live set and have it react to the music, and it really opens up the door, because once again, the simplicity can let you take these building blocks and kind of combine them in different ways and combine them with different disciplines. And it's really, I don't know, really exciting when you start going into the like real-time territory.
I think it's cool how we all on the panel here use fractals so differently. I mean, you've been doing a lot of procedural texture work, like getting things come to life with fractals, basically, instead of having every render look like Singapore airport, which is like, VR with bad resolution because everything is super clean and lifeless.
I've never heard that. That's pretty awesome. Absolutely, and the way it inches into other pathfinding algorithms and all this kind of stuff is what makes us, I think, lots of us probably use it already without knowing, like that you use fractal algorithms and the idea of self-repeating and self-emergence out of self-similarity in life and in your works if you do kind of VR graphics. And I think that's the cool part, is that once you discover fractals visually, like we all do, is you realize what happened through time with you. And I really like the idea of, for example, for a piece like Coral, which is right now a fractal visualizer and an art piece, to actually make it a game, but then make every part of the game a fractal, like from the pathfinding algorithm of the enemies to the level design to the way you have to think. It's a very interesting idea. Once you put people into a mathematical formula like this and give them a headset, will there be some weird intuition appear in the human brain that we can actually use those and manipulate those? And I can tell you from having spent literally days probably, or I mean, not probably, definitely in fractals in VR, like at one point it's just, what's around the corner somehow, ish. And you're still getting ish, and you're still getting surprised on different scales. That's the crazy part. It's like I distinctly remember we were moving around some sort of Apollonian fractal at one point, and everybody in our little circle of graphics programs had to stop for a second, because one of you guys added in a place where literally, so an Apollonia is a fractal which is very like spongy and sphery, and then we basically went through a hole into another thing, and suddenly there was one sphere in the middle of nowhere. And knowing what we know about the algorithm means that everything we've just done is in that sphere again. But you've just basically found the seed that makes, on a big scale, the same thing that you can then fly in, which is very Inception-esque, and mind-boggling, but it's super amazing.
Fractals are a great way to just make anything look more natural. And like going back to the early days of computer graphics, like Ken Perlin won an Oscar just for adding noise into an image because computer graphics were too flat at that point, and real life is noisy. So this is sort of the next level of that. It's not just noise, it's like 3D structures and things that you actually see in the real world that we can now bring into all these sort of interactive art experiences, and it really makes it that much more powerful because, like Johannes was saying, it is a really natural thing that your brain kind of fundamentally responds to when you see these kind of shapes and patterns.
There are some pretty fascinating theories among psychologists also that the visions that people see using various illicit substances are actually representing the fractal nature of our thought patterns.
All of a sudden they make sense.
Absolutely, and we always call Coral the closest to taking LSD without taking LSD. So it totally lets people trip out for if you kind of have that loop in you.
See there how technology puts people out of business.
What's interesting too is that how much the advance in computing power has made fractals so much more accessible, and now that it's even possible to do them in real time, and I think that has made them more out there in the world and more accessible, and with software that you can download for free, you can start making your own fractals.
That's very true, and also how fractals were discovered in the first place. I mean, people knew about fractals back in the 1800s. That's why Julia sets are called Julia sets. It was a French guy named Julius who discovered them, and people knew that they were there, and they were called monster curves at the time among mathematicians.
Don't Google monster curves ever.
No, that's really down the rabbit hole. But so people knew that they were there, and Benoit Mandelbrot, who discovered the Mandelbrot set, he was actually trying to draw Mandelbrot sets by hand using pen and paper, and that's a pretty tall order to complete. But when he started working at IBM in 1975, that's when he got access to computers. So he could start feeding these algorithms into computers and iterating on them. And I think it was in '78 that the first color fractal was printed. And that was on the cover of like National Geographic and Newsweek and Time magazine, and it was a very big thing because nobody had ever seen it, and he himself was surprised by what he saw because he wasn't prepared for that at all. There was no way that he could have guessed that what those patterns would look like, and then zooming into them would just bring up new stuff, and this sort of self-replicating, these self-replicating shapes that are self-similar to a degree, like self-similar-ish. But once you go down basically any fractal, if it's a true fractal, you will find stuff in there that nobody has ever seen by the very nature of things. So go into a fractal, turn to the left, turn to the right, go up, go down, and you will see something that no human eye has ever seen before, ever. And that's what it's like.
That's why Coral is a different experience every time.
Really
you
pushing
do it.
this product.
No, it's not a product. That's a trick. I'm not pushing a product.
Oh, okay.
It's you versus the LSD
it's not a
dealers.
product. It's actually it's not a product whatsoever.
Oh, okay.
You cannot buy it. You cannot give us any money for it. No, it's just.
You guys stay in business. I don't know.
That's not my department.
Oh, good.
I'm into making cool shit department.
You do special
not
effects
into
for free
making
as well?
money department.
This is the art side. We don't do business over here, guys.
No, what I like about the whole site is also the community, because there is a very vivid, obsessed crowd out there who are really helpful, who are really like-minded, and are really in, and I think in the same headspace to do all this. And there is lots of help. There's lots of documentation out there over the years. And while not being a historian on fractals myself, the way it was discovered was literally by people getting interested into the subject and going more and more and more into the matter. And everybody can do it. That's the good part about it.
If you're on Facebook, you can search for Mandelbulb Maniacs, which is a great group. It was started like 5-6 years ago, I think. Yeah.
I only know it since 2 or 3 years. So.
We were like 20 people on there at first, and now it's, I think, 25,000 people. So you can download software there for free, and you can, start messing around with it. And one thing that is also cool, instead of just, doing your own really badly drawn fractals that look like a big pile of something, you can, if you see a really cool fractal that you really love, you can download the parameters if the artist shares them as a text file. You just copy it and you paste it into a program and you render it on your own computer, and then you can start exploring their fractals. So you get like really, really professional looking fractals for free. And anything that you create in them, you just share it to other people, and you color them in, and map them in which way you want and tweak them. We call it tweaking. So if you post one of those, that's a tweak by perhaps Johannes or somebody.
I'm not tweaking, don't worry. Twerking is what I understood first. No,
You're really good at it.
There's actually, it's a very exciting time because there's a very prominent fractal artist called Julius Horstius, who actually has, while being very active on all the forums and being very present in the art space, recently announced that he has actually stopped being a VFX. I think his day job was working in visual effects, and has announced now that he's kind of the world's first fractal artist who kind of makes it as his sole income, which is actually quite cool and interesting that it's possible now. He had shows at Coachella and stuff like that. So I think so did you guys. I think everybody knows each other in this community by now, I think.
This is the greatest part about like fractals. Like Anders was saying, they were discovered. Like Mandelbrot discovered a lot of fractal stuff in the 70s, and you're talking about art and math. Those go back centuries, and a lot of that stuff has been like overstudied, especially on like the math side and the art side. But now you can do this kind of stuff that you see on the screen, and it's only been around for like 40 years. So you can have people like Julius, like today, the first professional fractal artist, and it's like just happening right now, which is the coolest part. And then couple that with the now we have VR and the computing power to actually generate this kind of stuff in real time and make it so much more accessible to all you people in the audience. If you're interested, you could just go download a program right now, or when you go home, and start tweaking these.
Doesn't work on phones yet. We're still working on that.
There's a very cool iPhone app called Frax, which is actually incidentally made by the same programmer that wrote my favorite software back in the 90s when he was 17 years old. So Frax with an X, that's sort of 2.5 dimensional Mandelbrot sets, which is also pretty cool, and that generates in real time as well. Not fly-throughs of 3D objects like Johannes' very, very awesome Coral does.
It's not a product. Yeah, absolutely, and I think the cool part about it, beyond that, is just to hammer this point home, is that it doesn't stop there. Like visually, it's cool. There's artists, but it works for the math majors amongst you, the physics majors, and the philosophers at the same level, which is actually quite astonishing. I do not know any other concept that is that far spread. Might be there is one, but I just can't come up with one right now. But I think there is a beauty in that it's connecting people that are graphics nerds with people that are liking to look at stars, with all those kind of subjects which are otherwise not that related.
Perhaps we're sort of moving closer to a time where, just like Euclidean geometry, and by Euclidean I mean spheres and cubes and normal geometry. Have been used in art and architecture and production and engineering for thousands of years, because basically it's geometry and mathematics that gave us everything that we have today. But fractals being sort of another level of geometry in nature, I think perhaps we're moving closer to a time where, just like artists have been using Euclidean geometry, they will also be using fractal geometry in like a more natural way. So I don't think we will have fractal artists for much longer. We will have artists using fractals, just like you guys are doing, in films. It's not a fractal movie. It's a movie that uses fractals to achieve an artistic effect.
I'm thinking of the next Frank Gehry building that might be a fractal, a Mandelbulb, or a Mandelbox. That would be cool to see.
It would be awesome.
It will be very natural, at least.
Well, they've got the 3D concrete printers, so really there's nothing stopping them at this point, I think.
Yeah, with 3D printing now, and we've done, one of our artists at Disney has done he did some tests using our Mandelbrot algorithm to do some 3D printing. It's a bit of a challenge for a 3D printer.
It is printing something that just consists of holes. That's an interesting challenge.
Yeah.
I mean, normally you just sort of hollow out your object to save on printing costs, but with a fractal, that's a pretty tricky proposition. But it's doable.
So it sounds like most of working with fractals, particularly for an art project, is about discovery and exploration rather than what we traditionally think of, which is working from like concept art or working from a high concept and then working back to something that actually exists. Can you guys talk a little bit about the difference in process, particularly, you know, I know some of you guys are working with teams, some of you guys are working solo. So how does that work? Do you just pick numbers and dive right in? Do you have a library of fractal images in your head and you know, okay, I kind of want to do this thing that I saw this one time when I added a 4? How does that sort of play out for you guys?
With 3D fractals, I usually start with combinations that I've been able to get good stuff out of in the past. Because otherwise, just starting from scratch with 3D fractals is, let's say it's trial and error and a lot of error, like 99% error. It can take me months sometimes to find, you know, a nice new fractal. And when I say fractal, I mean a combination of different fractal algorithms that I combine. And moving them around also changes the fractal. So if one fractal comes first and affects the second fractal, if I change those positions, it creates something completely different. And touching any of, you know, the values or the sliders or elements of either of these also changes things completely. So sometimes I use up to 6 different algorithms in combination. So I tend to go back to stuff that I done in the past. Sometimes I just start from scratch. But it's a lot of exploration, finding the cool places. And just like Johannes were saying, it's you find unexpected things in there when you least expect it. I've been exploring the Mandelbrot set for, 30 years and more. And I still find stuff in there that I had no idea existed. Just when I get bored and I click and click and click and find nothing, that's like, what is that? And that's part of the fascination. It's a bit similar to nature photography in a sense, fractal exploration, because a nature photographer didn't invent the forest, he didn't create it. He just walks around in there and look for cool stuff and cool shades, and maybe he, you know, fixes the light in post, just like we do. But otherwise, it's very similar. I didn't create a fractal. I never did. People do sometimes. You know, smart people like these guys. I just explore them like a photographer, pretty much. And I see something cool, and I stop and I take a photo. And sometimes I bring it back with me in VR or print it out as a mesh object.
At Disney Animation, we have an art department that would usually generate visual development artwork that would inspire us for when we're creating the images for the final film. And when it came to working on Big Hero 6, and my supervisor on the show, Michael Katshock, had this idea of using fractals on the film, the art department was a bit flummoxed, and they didn't really know, how are we going to paint that? How are we going to pitch this to the directors? Because the normal procedure would be to create still art, paintings, either in Photoshop or traditionally. And there was a leap of faith there that they were willing to take and let us sort of explore for a while. And I had never worked with fractals prior to that. But it paid off well in our very early tests, which did not involve color at all. They were purely monochromatic. Were a huge hit with the directors. And in fact, the director, one of the directors, when he first saw one of our very early tests, he took a look at it and he paused. And he said, I think I'm going to start believing in God now. And it did have that kind of effect on you that this was something that could never have been created by the human hand, and yet we somehow did it.
That's a strange thing about fractals, this sort of the very first thing that I felt starting exploring fractals, I was working as a visual effects guy back in the day. And then this guy at my work, he had this really weird program open, and it was a Mandelbrot set explorer, like the very first one. And so when he left, I just took over his computer and started clicking away. And it was this weird feeling of sort of diving deep into this rainforest of weird shapes that never ended. And at least to me, there was some kind of really strange sense of something going on beyond my understanding that was mysterious and kind of awe-inspiring. It wasn't created by anybody, it was just there. And it had been there forever, but only nobody knew about it, which I thought was very, very cool. And doing that in VR, I think, sort of amplifies that sense. If I find a really cool spot and I render it out for VR and just put on my headset, there's very often this strange sense of almost a presence, almost the feeling that you get when somebody's looking at you from behind or something. It's not really that, it's something similar. I don't know what it is, but it's just maybe some psychological effect of the shapes themselves on a physical level. But it's a cool aspect of fractal exploration.
Yeah, that's what we were trying to capture for our images. And it was that specific feeling that you're talking about, like a physical reaction to seeing these images, that what we were trying to capture. And it doesn't happen with every fractal pattern. There are certain ones that we found that kind of triggered that.
That's another aspect of, we're talking about processes and how we go about creating images. For me, creating a sense of scale, which you succeeded in doing, amazingly well, because that thing looks like it's huge. And fractals don't have a sense of scale. I mean, they're infinitely small or infinitely big. It's all subjective. So creating a fractal image that looks huge, you need to go about it in a way that fools your mind into thinking that it's big. And I do that by creating a really, really high level of detail. Because if it has a lot of detail, your brain will think, oh, that's big, that looks like a skyscraper, because it has windows-looking things on it. So it must be, very tall. And using fog, for instance, which is also just a purely mathematical function, just distance fog, which is in any 3D program, that also creates a sense of depth. So that takes a long time for me to get that right, and I guess for you guys as well. And you do that too in real time.
I'm still a non-believer, but even having spent that much time in fractals, but you're right that it creates this, for me personally, it's this quite literal anecdote of how the universe works, in the sense, or at least that I believe it works, isn't like there's multiple universes and there is different scales and there's stuff that happens on a very small scale and there's stuff that happens on a quite big scale, and we call this a chair. And even if we know it's made out of atoms and we could describe it as a bunch of connected particles, it's still a chair at the same time, depending on what scale you're looking at it. So I think that's what drives us, and I think what drove us to making the experience is primarily to really experience this. Besides the fact that it's cool to fly around in a fractal, but to really go after this scaling. So what we do in the unnamed experience is that the closer you get to a shape that you perceive as big, the smaller you are becoming. So you cycle through and you're not getting told that you're shrinking. You just do it. So basically, we shrink your eyes together. So you go from a human person to the size of a bacteria, probably over the experience and back out. And we just do that. But the closer you go, the smaller you get, the more detail on that scale appears, and so forth. And on the way back out, it's this weird powers of 10 kind of logarithmic scale that happens, which is amazing. Because we can't have your computing power in real time, are currently bogged down at a certain scale, because what we experience is that at one point the floating point precision of the computers is in the way, because at the end of the fractal, the virtual VR fractal, everything starts to look like Minecraft, because everything gets discretized into these cubes, and the cube is actually another really interesting property that you can suddenly visualize is the edge length of one of those cubes is basically the smallest floating point number that is currently available to be represented. You just can't divide this any smaller in a computer. And I think that's a very fun way of visualizing this kind of weird tiny number phenomenon, which we kind of fell over. If anybody has a brilliant idea on how to make a float smaller than float min on a GPU without losing performance, please let us know.
Nick, how about you?
Well, I guess the exploration kind of aspect is my main motivation for doing real-time fractals, because like Unger said, it's like 99% error like in the trial and error, and there's a lot of like empty areas that don't look that cool, or like boring areas, or just nothing if you have the wrong parameters. So if you're doing it in real time, like my experiments with VR fractals are a little different than Johannes's, where it's totally open-ended and you can zoom into anything and change all the parameters like by grabbing these little blobs. And if anyone has a Vive, you can download it from these links on the screen here and try them out. But that's like the main I draw to it, is that you can jump into these worlds and explore endlessly, and it just keeps going, and you can't get infinitely small because of floating points, but the algorithm keeps going. It still exists. You just can't represent it on a computer in the same way. So that's, I guess, yeah, the main reason I've been doing real-time stuff is so you can just iterate and explore more and more and change all these parameters much faster than like waiting an hour to render something and you're like, oh, this is crappy.
And just to actually answer your question about the process, for us, it is it's similar to what you just said. Is we were lucky that because we had something, a quick prototype in a couple of days that looked interesting, that inspired people to. It was broken. You almost got super motion sick, and all this stuff. You had a uncolored version of what you did, and you showed it to people, and it inspired people at the studio enough to give you the time to actually do the exploration, which is not very effectsy thing to do. If you have an R&D project that you want to do that is not backed up by a show directly, you have a hard time getting that through by getting people to believe in your technology that it will save you money, it will look pretty, but. In this case, I think we both were lucky enough that we had this opportunity, and at the end of the day, if giving enough people enough time and the algorithms at hand, you just happen to create something beautiful, even on your own. You're mainly working alone. For us, it's a team that's slowly growing, so everybody who's interested is like, just try it, just add a couple of lines of shader code and see how it looks. And on top of that, we were obviously trying to crack the nut of VR rendering for this stuff. So we do a lot of reprojection of one eye to the other, so we only have to render one eye. We do a lot of tricks while we ray march through the functions at different scales, at different resolutions, to come up quickly with a pleasing result. And it's fun to we had a GDC talk about it, and it's fun to just do the purely technical challenge of rendering something in real time. But on top of that, again if you then are in that system, then you are, as an artist, you can just start to explore.
Yeah, I've also used a bunch of fractals in TheWaveVR as sort of environments and textures and 3D physical objects in VR. And you have to make a lot of compromises, one, when you're doing real time, but also when you're using it in a game, because there's a whole lot of other stuff going on, and it's not just about fractals. Like, it's a tool.
Speak for yourself.
It's a tool that you're using to just like create an environment or create a feeling. So there's a lot of back and forth with, oh, we want it to look good, but we don't want it to use all of our rendering budget, and how that's a fine balance you have to strike, like working with a team that way.
Excellent. Well, we are almost out of time. Do we have any questions from the audience? Anything you want to know? All right, we got one.
Hi, I'm really interested in fractals, and for a while I've been looking into it in the quest of what beauty is to people on a big scale. And then I start looking at asymmetry, which is the opposite, and fractals can lend themselves to that. But asymmetry equals growth, which is natural for us to kind of gravitate towards. I didn't know if you could speak to your thoughts, if you have ever considered any of that.
Trying to come up with something smart to say.
I know it's a big thing to drop at the end here, but.
I mean, you go ahead. If you found a smart thing to say, I'm still thinking.
Not particularly smart,
Fractal.
just I mean, your question sort of is at the heart of the matter itself. I mean, fractals are asymmetrical. That's what they are. So they only represent growth in that sense. So I can't think of anything smarter to say, but I think you're right on the money there. But I mean, this goes with the territory. I mean, how do you describe fractals? If anybody has a good definition, I mean, you know, that would be nice.
the growth projection, I think, is very, very important. And being asymmetrical but still beautiful, while I mean the classic sense of beauty, where symmetry apparently seems to be what people like. But then, do you really want somebody perfectly symmetrical? Like, I think the real essence of beauty, if you want to distill it down to that, is somebody who has, you know, a feature that you can lock onto. And I think it's a similar thing with fractals, that you have these patterns, and if you like them, they appear at this scale and at this scale and at the humongous scale. So I think that's why it's a very good analogy for real beauty.
Can I throw one more other thing in there real quick? Yeah. With that being said, do you ever find that people find it more interesting if you make imperfect art versus perfect art?
Well, there's no such thing as perfect art.
Except mine.
I think that comes with being widely in the visual effects world, is if you make something that is absolutely real, it might actually not be real. Like, how often do we take pictures of a sunset, and, you know, like, if I would render that, I would get slapped by a supervisor. But it's actually what happens in nature. So I think that imperfection is what makes everything real.
I just try to, you know, take a photo of yourself, go into Photoshop, and just, you know, reverse flip both sides of the face. It looks pretty unattractive. It looks very strange. And I think that maybe perhaps because it loses all sense of presence.
Yeah, thank you.
We have one more question. Time for
Long
one
line,
more.
dang
Just
it.
one more, I know.
All right, I'm just going to ask the question and let you guys answer. Go ahead and sit down. Have any of you done any tracking of what actually is happening in the brain using any fMRI technology when you're experiencing any of this? I mean, my path is more into a therapeutical application of it, and we're trying to build a repository of what certain images evoke as far as sight and sound. So have you approached any of this medically, or are you tracking any of it as far as what's happening in the brain when the experiences are?
I have not, but I know that there are quite a few psychologists that are looking into that, and psychiatrists. But I haven't heard of any study that's been made, but it would be fascinating to be part of it, wouldn't it?
Certainly would, yeah.
And I second that. If you have any sort of access to, the problem is with this stuff is it's not as easy to have a medical study of the brain than, you know, wearing a heartbeat sensor. But if there's anybody who wants to have people experience fractals and measure their brain activity, and I'm sure there is something. It's just, you know, as a visual effects company, our MRI scanners are constantly in use. It's just, we can never get access to them.
Okay, well, thank you. We are out of time. Gentlemen, if you could please stand up and take a bow for burning an entire hour talking about fractals, which you warned me you could do. So this was awesome.